All right, so what we're going to do is all of 9.2 first, and then the last couple little slides that are on here are some things from 9.1 we didn't get to yesterday. So this lesson is a continuation of what we did yesterday with the correlations. So we talked a little bit briefly about like a line of best fit, a line that would show the general trend in the data. So that's what we're going to be calculating today, is that slope and y-intercept that'll give us that line of best fit. So it's also called a regression line. First thing we talk about when we talk about a regression line is what are called residuals. A residual is the difference between an observed value and a predicted value, and that's what it says at the bottom of this slide. Observed value versus predicted. So an observed value is the actual point on your scatter plot, or the actual data value from your set. The predicted value is the value we get by plugging that number into the equation we find and then solving for whatever the y value is. So maybe like let's pretend when I see that little D3 there, that's an x value of 5. So the actual x value of 5 is maybe at like 10, but my line's predicting if I plug 5 in, I maybe get 8. So the residual would be the difference between those two, 10 minus 8. The 2 tells me that the observed value is 2 units above what's predicted. It could also be negative, and that tells me that the observed value is below what's actually being predicted. So it just tells me how far off I am when I calculate a residual. Okay, next thing that we kind of have to review with regression lines is stuff from Algebra 1. Lines of best fit. We talk about slopes and y-intercepts, so you have to be able to recognize those. I'm going to number these at the bottom. So let's call that 1, 2, 3, and 4. We're going to try to match these graphs to their lines of best fit, so their slope and y-intercept. Remember, slope is rise over run. It's positive slopes going up, negative slopes going down, and then y-intercept is where it's touching the y-axis. Now, these ones, they didn't extend the line all the way through, which I don't love, but you can do that yourself to just approximate where it's going to cross the y-axis. So for that first one, letter A, which of the 4 equations at the bottom do you think would be the best fit? Number 4. So it has a negative slope because the line's going down. That's the number in front of the x. And then it looks like about 27 is where it's touching the y-axis. Okay, what about letter B? Number 1. Okay, so again, it has a negative slope, and that's actually the only other one on the list that has a negative slope. Okay, what about C? 2 or 3. Why 3 and not 2? They both have similar slopes. So the intercept, if I sketch that, crossing, I would say more at 22. This guy, that's going to be closer to 9 or 10 there. Okay. Does that make sense? Any questions on that? Okay, so calculating a line of best fit, these formulas are at the top of that paper that you guys got yesterday that had the Pearson correlation coefficient critical values on it. It's also on your paper here if you want to, but you can use the other one if you don't want to flip back and forth. All right, so when we're finding the line of best fit, it's y equals mx plus b like you've used in the past, but it's from a sample. So instead of a y, we're using a y hat with the little kind of caret above it. You have 2 formulas to calculate slope and y-intercept. Slope formula, you notice, is really similar to what we did yesterday. Actually, the numerator is exactly the same. The denominator, we only use the x piece versus the x and the y piece that we did yesterday under those square roots. But we're going to find those things similarly. We're going to have all those columns in a chart, and we're going to find all the sums at the bottom, and then we're going to plug them into the formula. The y-intercept, they actually write the formula 2 different ways. Y bar and x bar just mean the average of the x's, the mean of the x's, and the mean of the y's. So you can think of it that way. And what you see here is just how we calculate the average of x's, or the average of y's, right? We add them all up and we divide by how many there are. So that's all this is telling you, but either one can be used, okay? So we're going to fill out our big columns. We're going to find slope. We're going to find y-intercept. We're going to write the final equation with a y hat. All right, so let's do one. So here we want to find the equation for the regression line for the data below. X represents hours spent studying. Y represents test score. So first thing I'm going to do is just put these in columns instead. So let's fill those in. 0, 2, 4, 5, 5, 5, 6, 7, 8. My Y's, 40, 51, 64, 69, 73, 75, 93, 90, 95. Okay, and then in order to use these formulas, we're going to need the product of x and y in a column, and we're going to need x squared. We just don't need the y squared that we did yesterday. All right, so x times y's, first one's going to be 0. Second one's going to be 102. 4 times 64, 256. 345. 365. 375. 558. 630. 760. Take all my x's and square them. 0, 4, 16, 25, 25, 25, 36, 49, 64. And then we're going to sum them all up. X's are 42. Y's are 650. XY's 3,391. And 244. All right, so that's the part that just takes a minute. What's n in this problem? We did that yesterday. What is it? 9. Just the number of pairs of data that you have. And then x bar and y bar. So this is where you could use this, the sum of the x's divided by n, the sum of the y's divided by n, and we already had the sum of the x's and the sum of the y's there. We did a little of that work. So I'm just going to leave it exact, 42 over 9 and 650 over 9. The 42 over 9 definitely reduces. I don't think the 650 over 9 does. We're going to plug these into a formula anyway, so we might as well just leave them exact and not have to round and make our answer off at the end. Okay, questions on getting any of that stuff you need for the formulas? All right, so now we plug it in. We're going to do slope first. N times xy, sum of xy. So that was 9. I have to flip back and forth here, and 3,391. Minus the sum of my x's was 42. Sum of my y's was, I think, 650. All right, denominator. 9 times the sum of x squareds. Okay, so that's my last column, the 244, minus the sum of x, which is 42, squared. All right, and then we'll just type it in separately here, divide last. Oops. 3,219, right? Okay. Denominator, 432, and then we'll divide, and we'll get to 3 decimal places, 7.451. So that 3,219 over 432, that's the exact slope. You could always reduce the fraction if you needed to, but usually we're going to use that rounded version. Okay, go over to the y-intercept now. We already found the y bar and the x bar on the previous page, and I'll just use the exact values. 650 over 9 was the y bar, minus the slope. I'm going to use the exact one, 3219 over 432, times my x bar, which was 42 over 9. So nothing there is rounded. That makes sure that my y-intercept is going to be good. Okay. Let's see. Red calculator, you can put this all in one line as long as you put all those fractions in parentheses. And then again, this one's rounded, 3 decimal places, 37.449. All right, so final answer for my line of best fit, regression line, y bar equals mx plus b. And I'll just use the approximation, 7.451x plus 37.449. And we'll check that in the calculator in a minute. Okay. Interpreting the slope, and actually in this one we could also interpret the y-intercept. I added this at the bottom here. So you will be asked to interpret the slope, so state what it means in the context of the problem. So remember, slope you can think of as over 1, right? And it's rise over run, so my y's are what's on top, my x's are what's on the bottom. So in this problem, the 7.451 represents test scores. That's what our y is. And the 1 on the bottom is representing hours that you study. So what does this mean? It means for every 1 hour of studying, our score should, and then this is where it matters if my slope is positive or negative, because my slope is positive, we're going to say increase by about, I'm going to say about 7, I'll just give the whole number, that, and I'm assuming it's percentages here. Okay. You can also interpret in this problem, sometimes it doesn't make sense in the context, the y-intercept. Do you guys remember back from like Algebra 1, Algebra 2, what a y-intercept, what the x value is when you have a y-intercept? X value 0 is what a y-intercept is. So here, this would mean 0 hours of studying. We would have a test score of like a 37%. All right, questions, getting the line, interpreting the line. All right, flip your paper over. Let's check this with the calculator and do a couple other little things now that we have our answer. So we did this actually in the calculator yesterday. We're just going to add a couple things to it. So first thing I want you to do is take the data from this problem we just did and put it in your calculator. If you don't want to use L1, like I had somebody in 4th period yesterday that said their L1 was all like a project data and they don't want to delete it, you can put this stuff in L2 and L3. I'll show you how to change the list names. Okay. All right, so get them in there in 2 columns. That all in there? Okay, so hit stat, go over to calculate, same thing we did yesterday, number 4. This is where it should already say L1 and L2. If you put your data in other columns, you can change that by hitting second, and then if you hit the stat button, you'll see the word list is right above it. And then it'll just give you a bunch of list options that you can choose. So you can make your X's list 2 and your Y's list 3 if you want to, if that's where you put your data at. But L1 and L2 is just our default. The other thing we're going to do to save ourselves a little bit of time is we want to be able to graph this picture also, and when you do it in Math Excel, you're going to want to match. I think it's a matching problem. So we can tell the calculator to take the equation that it's about to find and put it directly into y equals for us. That way we don't have to retype it in and we don't have to round anything. So to do that, where it says store, we're going to hit vars, which is right below your arrows. Vars. And then y vars. Function. So we're graphing a function. And then you can pick any y that you want it to send it to. I'm just going to send it to y1. Okay. And then calculate like we did yesterday. And it tells me the slope, so you can check that we got that right. It tells me the y-intercept, so we can check we got that right. And then it also tells us our correlation coefficient from yesterday. So what kind of correlation do we have here? If my R is 0.968. Strong, positive, linear correlation. Yes. Okay, now if we want to see the picture, hit y equals, and we want to graph this superimposed on our scatter plot, so we need to graph the scatter plot. Your plot needs to be on. Mine is on because it's highlighted. If your plot is not on, go up to plot, hit enter, go back down. And then we want our calculator to zoom in on specifically our data, not just like a normal 10 by 10 window. So to get a nice window, we hit zoom, and then number 9, zoom stat, will zoom in on whatever statistics you have in your calculator. And then you should see this picture. Okay. So you can see my line doesn't have every point, but it's showing the general trend in the data. We have approximately the same number of data values above and below. It looks like it's hitting a couple of them exactly. Any questions in the calculator? Yeah.
I'm showing error.
Ooh.
Okay. Oh, it's because you have those. That's kind of. I don't know if that'll work. I think it's trying to zoom in on. So you could just do your standard window, 6, and then you could like change all your x values, from your 0 to 10, your y values, whatever. Or you could just wait and do that with those two. Yeah.
Uh-huh.
I don't have the R.
Oh, we need to do that from yesterday. Okay, so we're gonna hit mode. And go down to stat diagnostics and turn that on. Right now when you redo it, the R will show up. Okay. Other questions in the calculator yet? Hit bars, y bars, function. Okay, anything else? Calculator? All right, last 2 questions that are on this slide. It says, use your model to estimate the test score of a student that studies for 9 hours. So that 9 hours, is it an X or a Y? It's an X. Okay, so you need to know what to plug it in for. So what was our slope? 7.451 times 9 plus my y-intercept was 37.449. If it gave me a question that said, if I want a test score of 100%, how long do I have to study? You might have to plug something in for y and solve for x, so it could work either way. Plug that in, we get 7.451 times 9 plus 37.449, and actually we get over 100%, 104.508%. Okay, so that's question number 3. Question number 4, a student that studied for 9 hours actually got a 96% on the test. Calculate and interpret the residual. So the residual, again, is observed value minus predicted value. So our observed value is what actually happened. They got 96 minus what our model predicted. They got a 104.508. So if I subtract those, I get a negative 8.508. Okay, so what does that tell us? It means our, actually, let me put it this way. The observed value is about 8.5%, I guess here, below our prediction. Or you could word another way and say our prediction is about 8.5 above what we're getting. But the negative is telling us that the observed value is below. If it was positive, it tells us that the observed value is above. Okay. Tells us how far off we are. Questions on that problem? Okay. So that's everything from section 9.2. That's all the stuff you'll see in that Math Excel. The last couple slides are just something that we didn't talk about that was in 9.1. We didn't get to it yesterday. It's correlation versus causation. So when we have a scatter plot, we have two variables that we're graphing, and we see a trend in the data. One goes up, the other goes up, or one goes down, the other goes down. But it's possible that even though we see that two things look correlated in the scatter plot, they actually don't have what we call a cause and effect relationship. One doesn't actually make the other one increase or decrease. There could be like this third variable, third factor that we have to consider. For example, if I graphed in June the ice cream sales daily and the number of people that got sunburned at Lake Cable daily, as one increases, the other would likely increase. Does that mean that my ice cream sales are causing people to get sunburned, or sunburn are causing people to buy more ice cream? No, both of those are changing in a similar way because it's summertime, right? Okay, so this is an example of, we see a correlation, but the causation is something else. It's not a cause-effect relationship. So last couple problems, there's an example at the bottom. We'll do this one together. We have two variables that we could make a graph of, and they're shown to have a correlation. So we see a trend in the data when they're graphed, but there is no cause-effect relationship. Give at least one possible explanation that we're seeing that correlation. So remember, one could go up and the other could go up, or one could go up and the other could go down. Either of those could be a possible explanation that we're looking for. Here we have value of a home and lifespan. So let's say as value of a home increases, lifespan increases. What is one other variable that could make those both happen simultaneously? There's one thing that could affect value of a home and lifespan. Any ideas? A tornado. Okay, so if you live in Tornado Alley in Oklahoma, right? Then your value of a home might decrease because there was a tornado and your house is destroyed, and there was a bad tornado, so lifespan also decreased. It's a little morbid, but okay. What about like wealth? Could that change something, right? So if you live in an affluent community, your value of a home is going to increase, and likely that means you can also afford very good health care, and your lifespan would also increase. Okay, good. All right, so you can be creative with these. There's not one right answer. Try these three. See if you can think of a reason. Then we're going to share out what could be the cause-effect variable here. What is making both of these change that it looks like they are correlated with one another? Remember, they both could go up, or one could go up and the other could go down. Could be either type of correlation.
Fair.
Where did you come up with this?
I did your textbook. Weddings on the lake.
Do we have ideas for each? Okay, what could cause a correlation between ice cream sales and homicide rates? I would love to hear actually what you think, and then I'll tell you what I think. I feel like mine's gonna be a whole lot more boring than yours. What do we think, Lauren?
We said kidnapping. So kids like get it. So there's more kids that come because they get the ice cream truck is coming.
Truck, the
And
white
then-
van without the windows.
Yeah.
Yeah.
After there. Yeah.
Okay.
So
Increase in kidnapping would give an increase in ice cream sales and homicides rate. Yeah, yes, good. Right answer. Okay. What else? I just said warmer weather would cause ice cream sales to go up and homicide rates to go down because people are happier. Right? Okay. All right, what about alcohol use and tobacco use? What could cause it to look like there's a correlation between those two variables? Any ideas? Price? Okay, explain.
Like a low price for alcohol.
Okay.
Also tobacco.
Okay, so like economic state in general could cause both to go up or both to go down, depending on which way you look at it. Sure, yeah. Good. Anything else we want to add to that one? Okay with that? All right. Marriage rate in Kentucky and number of deaths caused by falling out of a fishing boat. Any thoughts? Yes.
We said like honeymoon trips. People get married and then they fall out of the boat.
So they're taking the trip on the lake. Yes. Okay. So there is a spike in lake honeymoon trips, and therefore our weddings go up, and so do more people on our boat, so they fall out of the boat. Yes. Absolutely. Anything else you want to add to that one? First period was talking about pushing people out of boats and happiness of marriages and all kinds of things. So, all right, that's good. I'm good. Okay. So, deadlines. 9/1 is Math Excel is due tomorrow night. And then so is your project. Not tomorrow night, tomorrow in class. When you walk into class, if you're not here tomorrow, what should you do? You need to email it to me. If you do not email it to me, you will get a 20% deduction. So please email me your project if you are not here. This Math Excel for today is due on Monday. Those are your last Math Excels. Okay, tomorrow in class then, after you turn your project in, like I said, you're going to have Mrs. Benson. And you will have the whole period to work on this quiz. It is take home. I think that you will likely finish it in class tomorrow and you can just turn it in before you leave tomorrow. But if you don't, you can keep it over the weekend and it's due Monday when you come into class. So this has to do with the feed collection, handstand that we did earlier this week. I'm gonna give you that data in a minute. It was actually meant to be done with a shared large bin of M&Ms that we were all gonna put our hands in, but I thought that sounded gross. So that's why we did beads as a replacement. So we're gonna pretend all of those beads you grabbed were actually M&Ms, and I'm gonna give you M&Ms because you deserve M&Ms, okay? But that's what this project's about. So let me give you, here is the data that you guys collected this week. Okay, so before you leave right now, write down this data on the first page, okay? And then you're going to use this data to answer all the questions on the quiz. And then Mrs. Benson will be here. I don't think she'll be able to probably answer any questions, but this is your task for tomorrow. That way she can pass stuff out to you or explain it, okay?
Wait, is it like group quiz?
You may work together on it. You're going to turn your own in. But yeah, you can definitely work together on it. That's fine. You can use your notes. Everything obviously should be done without a graphing calculator. Yes. Oh yeah, that'd be fine. All right, so questions on that? Okay, so that was our last lesson before the final. Last project's turning in tomorrow. Last 2 Math XLs. This is the last quiz. We're wrapping it up. Next week, final exam. All right, I'll get you guys each 2 bags of M&Ms. You can eat them today if you're hungry, or you can save them for tomorrow if you want to be, I guess, in the spirit of the activity.
I had a question about this is like you tell if it's skewed right, left, how do you
Turn on the side and curve over it. Whichever way the tail is which way it will be skewed.
So like if there's more over here, then it'll be skewed.
Well,
Be like,
this is pretty symmetric.
yeah. It's like 4 here, but like,
Yeah.
I think there's
It's actually lower on this side, so that's where your tail is going to be, because it's
Okay.
lower there.
So I go skewed right or skewed?
I would say it's more symmetric than anything.
Okay, thank you.
And then, eat them today or tomorrow, what do you want to do? Yep. No, this is the.
Yeah, what?
Someone measured it wrong.
Oh,
Yep.
What was it? How'd you get 23? I know that. I didn't hear it. What? I didn't study. Of course. Okay.
Estimating that is what?
Is literally 9 degrees. Like I literally got the same thing.
Symmetric.
Yeah, so I don't know how.
It's not going to be a kind of values that are like all.
Yeah.
It could be slightly confused. It's not going to matter anyway. We have to worry about. Thank you. You're welcome. There you go. Yep. All right. Oh, I got your cell phone on.
Watching the game 2 days in a row. She'll pull the star.
24.
Well, man, screw it. It's a waste of time.
Everybody got their data copied down?